Hey guys, so I don't have the solutions written out to these, so I was just figured I'd record a video as I finish filling them out, and then I'll post the solutions and the video for you for the ones we didn't go in class. So we did do both parts of number 1 in class, so I'm going to go ahead and jump into number 2. And again, I'm using that first formula here, the f of x minus f of a1. So if you have the function f of x equals 1 over x, and I'm looking at two different limits here. So to start, I'm going to go with the limit as x goes to 1, because that's the first x value. And I'm going f of x minus f of 1 all over x minus 1. Okay, and so this is the limit as x goes to 1. And I replace f of x with the function that's written. So that would be this one. So that's 1 over x minus, and then f of 1 just means plug 1 in for x. So if I plug 1 into the purple one there, 1 over 1 is just a 1. And I have x minus 1 on the bottom. Okay. In order to clear my fractions, get rid of my fractions and fractions, I'm going to multiply by the x that is this little denominator right here. Right? So if I multiply by x, that'll clear out that denominator. What that does is this gives me the limit as x goes to 1, and I want to make sure I distribute it to both pieces. So x times 1 over x is 1. 1 times x is just x. On the bottom, I have x times x minus 1. Now, of course, the idea behind this is I'm trying to cancel out this piece, right? Because that's what's making it 0 over 0. So I need to cancel out the x minus 1. And I almost have the same thing in the numerator, but it's in the wrong order. So anytime that happens, we fix that by factoring out a negative 1. So this will be the limit as x goes to 1. And I'm going to factor out a negative 1. When I do that, it becomes negative 1 plus x, or x minus 1. And if you're not sure, you can kind of check it going backwards. But that's how you flip the order of subtraction. You multiply it or factor out a negative 1. And then that allows me to go ahead and cancel that x minus 1. So I'm going to have the limit as x goes to 1 of negative 1 over x. And then now that it's canceled, then I can go ahead and plug in my 1 and evaluate the limit. And I get negative 1. Okay, so there's the first one. Number 2, we're now going to go and do exactly the same thing, only x is going to be 2. So I'm going to go over here and we'll do it in a different color. So then we're going to have f prime of 2 this time is the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. That's the limit as x goes to 2. And now the f of x was the 1 over x. That's our function. And f of 2 is plugging 2 in for x. So in this case, that's 1/2. And my x minus 2 stays on the bottom. Now, in this case, I have two denominators that I need to clear. I need to get rid of the x and the 2. So I'm going to multiply by both of them. So I'm going to multiply by 2x. Top and bottom. And what that does for me is that makes this the limit as x goes to 2. When I distribute this to this term, the x's will cancel and I get just a 2. When you distribute it to this term, the 2's cancel and I get just an x. On the bottom, I've got my 2x times x minus 2. Again, we get that same situation that's happening where it's the same, but it's opposite order of subtraction. And I fix that again by factoring out a negative 1. So if I take a negative 1 out of the 2 minus x, that's going to flip it and make it x minus 2. And then I can go ahead and cancel my x minus 2's. And that gives me the limit as x goes to 2, negative 1 over 2x. And then I can just evaluate my limit and plug in my 2 to get negative 1/4. All right. So that's kind of how it works when it comes to our fractions. You often end up with that piece where it's opposite direction, and that just has to do with the fact that you're clearing denominators. Number 3, this is your square root. So we know we're headed to conjugates here. So again, two separate limits. Let's start with the first one with the x equals 4. So that's f prime of 4 is equal to the limit as x goes to 4 of f of x minus f of 4 all over x minus 4. Okay, we are again replacing the first f of x with the function itself. And our function this time is this one, the square root of x. So that's going to be the square root of x minus, and then we plug in the 4. So if you plug in 4, the square root of 4 is 2. and I keep my x minus 4 on the bottom. If you were to try to plug in your 4, you'd get 0 over 0 here, so we do more work. In this case, it's going to be the conjugate. So we're going to multiply by the square root of x plus 2 on the top and the bottom. Okay. That's going to give us the limit as x goes to 4 of. On the bottom, we're going to keep these things factored. So x minus 4 and the square root of x plus 2. On the top, remember that our outside and our inside terms when we FOIL are going to cancel out, so we don't have to worry about them. So we're just multiplying our first terms and our last terms. So that's going to give you the square root of x. Square root of x times square root of x is just an x. And then you're multiplying the second 2, which would be your negative 2 and your positive 2. And that's going to give you negative 4. Okay, and now it's set up. I don't even have to factor or do anything. I can just cancel my x minus 4s. And when I do that, that gives me the limit as x goes to 4. I have to hold the numerator with a 1 because I can't just not have a numerator. And then we've got the square root of x plus 2 on the bottom. If you plug in your 4, the square root of 4 is 2, plus 2 gives you 1/4. Okay, so that's our example of our conjugate. The one for x equals 9 is going to look similar. So we're going to have f prime of 9 equals limit x goes to 9, f of x minus f of 9 all over x minus 9. Now we replace. The function here is the square root of x. When I plug 9 into the square root of x, I get 3 over x minus 9. If you plug in your 9, you get 0 over 0, so we're going to use the conjugate here. So the square root of x plus 3, top and bottom. Again, the denominator is just these two quantities multiplied together. We're not going to distribute or anything funky like that. Just stick with what we've got. In the numerator, you're just doing the first 2 times the second 2. So first 2 get multiplied together. That gives you your x. And then your second 2. So negative 3 and positive 3 gives you negative 9. Again, in this situation, this is a nice one where it just cancels right out. I don't have to work for it. And I get the limit as x goes to 9 of 1 over the square root of x plus 3. Plug in our 9. Square root of 3, square root of 9 is 3, so 1 over 3 plus 3 is 1/6. Oh, that gave me a circle. Interesting. All right, so those are our square root ones. Okay, now let's go on to number 4, where we're doing our derivatives in general this time. So we're using the second formula, where f prime of x is the limit as x goes to, as h goes to 0, of f of x plus h minus f of x all over h. Okay, and so that's where we're starting from. So f prime of x, I'm going to write it out again. The more times you write it out, the more you remember it. The limit as h goes to 0. F of x plus h minus f of x, but I'm probably putting it on my note card just in case. Okay, now I'm replacing both of the top things, but not the bottom, so the h stays. F of x plus h. I'm taking my function that's given up here, and wherever I see an x, I'm going to replace that with an x plus h in parentheses. So I'm going to have 2 times x plus h squared minus 5 times x plus h plus 3. Now that's just this part right here, okay? Then we have to subtract the original function f of x. So I'm going to put that in parentheses, 2x squared minus 5x plus 3. Okay, so now I want to distribute and simplify everything. So let me go to the side and show you this for a second. So when you have 2 times x plus h squared, right? That's the same as taking 2 times x plus h times x plus h. That's the same as 2 if I FOIL out the second part. That's x squared plus 2xh plus h squared. So when I distribute the 2, I get 2x squared plus 4xh plus 2h squared. Okay, so make sure that you write that out if you need it. That's what I'm going to substitute here for this piece right here. Okay, so that means this is going to become the limit as h goes to 0 of 2x squared plus 4xh plus 2h squared. The next piece, we have negative 5 times x plus h. So distribute that negative 5. Minus 5x minus 5h plus 3. Now, on the second piece here, I have to distribute the negative to everything that's in the parentheses. So minus 2x squared plus 5x minus 3. Okay, and now I have everything all multiplied out and it's ready to go. From here, I'm going to cancel out anything that cancels, and everything that doesn't have an h should cancel. So my 2x squareds should cancel. My negative 5x and positive 5x, gone. Plus 3 and minus 3. And everything else should have an h in it, which it does. So I should get the limit as h goes to 0 of 4xh plus 2h squared minus 5h. All over h. Okay, and everything should have an h because what I want to do next is I want to factor it out so I can cancel it with the one that's in the bottom. So if I take out the h, that's 4x plus 2h minus 5 all over h. Then I can go ahead and cancel these h's. That gives me the limit as h goes to 0 of 4x plus 2h plus 5. Okay, now that I got rid of the h in the denominator, I'm going to go ahead and evaluate that limit. And evaluating my limit means I'm plugging in 0 for h. So my h goes to 0, and this turns out to be 4x plus 5. Right? Remember that when I'm using this formula, my derivative, f prime of x, should be a function, not a number like it was at the beginning. This is about the level that you're going to expect to see on the exam. So make sure we're comfortable with our polynomials at the very least. Okay. All right, now I showed you number 5 in class. That was the one with the square root. So the only one left is the one with the fraction. So let's see if we can get this in here. All right, so same starting spot. So we're starting from the derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. So we're going to substitute. So remember that for x plus h, I'm taking wherever the x is, and I'm going to replace that with x plus h. So it's negative 1 all over 4 times x plus h plus 3. Minus the function as is, so negative 1 over 4x plus 3. All over h. And that gives me the fraction in fraction situation, which is always going to happen when you do this with fractions. You're taking a fraction and plugging it into a fraction. Okay, so what we want to do, we want to clear our fractions. Before I clear my fractions, I want to distribute this piece under here. So that's going to give me the limit as h goes to 0 of negative 1 over, distribute that 4. So that's 4x plus 4h plus 3. Now I'm also going to add the opposite. So we're going to have plus 1 over 4x plus 3 all over h. Okay, now I want to clear my denominators. So I want to clear this denominator and I want to clear this denominator. So I'm going to multiply by both denominators. So that means I'm going to multiply the top by 4x plus 4h plus 3 and the denominator by 4x plus 4h plus 3. But I also have to clear out the 4x plus 3. So I'm going to multiply by 4x plus 3 on the top and 4x plus 3 on the bottom. Okay. That way, when I go to distribute this to this fraction, the first piece will cancel and I'll only get the second one. And when I distribute it to here, the 4x plus 3 will cancel and I'll be left with the other piece. So we end up with the following. Let's see if I can get it on the screen here. Okay, so this is going to give me the limit as h goes to 0 of, when we multiply that out, we stick with the negative out front, and I'm going to be left with the 4x plus 3 part. Plus, in the second one, the 4x plus 3 cancels, and we're left with the 4x plus 4h plus 3. And on the bottom, we're going to leave all three of those pieces multiplied out just like that. No reason to distribute. No need to work harder. Let's just leave it. Okay. All right. Next, let's go ahead and get rid of our parentheses in the numerator. So let's distribute this. The second set of parentheses, there's nothing to distribute, so I can just drop those. So I end up with the limit as h goes to 0 of negative 4x minus 3 plus 4x plus 4h plus 3. All over h times 4x plus 4h plus 3 and 4x plus 3. Now I look for things to cancel. So I have a positive and a negative 4x and a positive and negative 3. So those all cancel. And now I'm left with stuff that just has h's in it, right? That's the theme here. So we get a 4h on the top and an h on the bottom with 4x plus 4h plus 3 and 4x plus 3. Then I can cancel my h's. That gives me the limit as h goes to 0 of 4 all over 4x plus 4h plus 3 and 4x plus 3. From there, we're letting h go to 0. My only h is right here, so that piece goes to 0. We're left with the 4 on top, and then 4x plus 3 times 4x plus 3. And when we square things, multiply something times itself, that's just that squared. So this is 4x plus 3 squared. And that is my derivative, my f prime of x. Okay. So there's the whole process start to finish. That's number 6. Hopefully that gives you a little bit of help with some of the algebra in these. And you can use those to solve the ones on the practice exam.